Welcome back to the Microsoft Azure Data Fundamentals course, where we are exploring the different data services and how to use them. I'm Krista Santos, your Microsoft Technical Trainer for this course. In this session, we're going to break down the core principles of structured data and databases and discover the power of relationships within data. This will give us a solid understanding of how to effectively organize and manage data in a way that drives smarter decisions. Let's get started. We're going to break down the core principles of structured data and databases and cover the power of relationships within data. This will give us a solid understanding of how to effectively organize and manage data in a way that drives smarter decisions. Let's kick things off by getting familiar with relational tables, one of the core pieces that makes relational databases so powerful. In a relational database, data is organized in tables, which you can think of as spreadsheets. These tables are made up of rows and columns. Each row holds a unique piece of information, like a customer, a product, or an order. And every row in the table follows the same column structure. These columns define the attributes or characteristics of the data. For example, in a customer table, you'd have columns for the first name, last name, and email address. Now here's the flexible part. Not every column needs to have a value. Let's say there's a middle name column for our customer table. It's totally fine for some rows to leave that blank or to have what we call a null value, meaning there's simply no data provided for that particular piece of information. Each column is also designed to handle a specific type of data. So for example, an email column would store text, which could vary in length depending on the email address. On the other hand, a price column in a table would store decimal values for currency, while a quantity column in an order table would be set to store integer values. And we can't forget about the date and time. An order date column in the order table would be designed to store date-time values, making it easy to track when orders were placed. It's worth mentioning that different database systems may have slight variations in data types they support. But most systems follow a standard set of data types established by the American National Standards Institute, also known as ANSI. So no matter what system you're working with, you can rely on a pretty consistent set of rules when defining your tables. Now I want to shift our focus to something crucial in the world of relational databases: normalization. Think of it like mastering the art of organizing your data for maximum efficiency. It's all about cutting down on the clutter and making sure your data is crystal clear and accurate. Let's start with a simple example. Imagine a company is using a spreadsheet to track its sales, and in that sheet you see customer details, product information, and prices all repeated for every single sale. The same customer's name and address appear over and over again alongside the product names and prices. It's messy, repetitive, and leaves a lot of room for mistakes. This is where normalization comes in. When we normalize data, we transform that chaotic spreadsheet into a well-organized system. Instead of stuffing everything into one table, we break the data down into smaller, more focused tables. For instance, we'd have a separate table for customers, products, and sales orders and line items. Each table would store just the relevant details, like the customer's name, the product's price, and so on. But here's the real magic. Each of these tables is tied together using something called a primary key. Think of it like a unique ID for each entry. So instead of repeating a customer's details for every order, we store the customer's ID in the sales order table, and that ID links it back to the customer's table where their full details are stored only once. Need to know a customer's address for an order? No problem. Just look it up using their customer ID. This approach keeps your data clean, organized, and efficient. One more important thing, referential integrity. It's like a built-in safety net for your database. Whenever you enter a foreign key, say the customer ID in an order, it has to match an existing primary key in the customer table. This prevents mistakes like trying to place an order for a customer that doesn't exist. Now that we've got a solid understanding of how relational tables are structured and how we optimize them through normalization, let's dive into the fun part, how we actually interact with relational databases. The language we use for this? It's called SQL, or Structured Query Language. But SQL isn't just any language. It's the universal communicator for your data. Think of it like a common language that all relational databases speak. And here's what makes SQL even more impressive. It follows a strict syntax set by the American National Standards Institute, ANSI, and the International Standards Organization's ISO. This means that no matter what database you're working with, SQL helps ensure consistency and compatibility. But there's a twist. While SQL provides a strong foundation, many relational databases have their own unique flavor of SQL, adding specific features and syntax. For example, you might have heard of T-SQL or Transact SQL for Microsoft SQL Server, PL SQL for Oracle, or PG SQL for PostgreSQL. Each of these has its own little tweaks, but at the core, they are all built on standard SQL. Now, you don't have to worry about all those variations right now. Let's focus on the 3 common types of SQL statements you'll encounter, each serving a distinct purpose in managing your database. First up, we have the Data Definition Language, or DDL. This set of statements is all about managing the objects in your database, like tables or any other object. With DDL, you can create, alter, or drop tables. For instance, when you use something like create table statement, like the example on the slide, you're creating a new table called products. Next, we have the Data Control Language, or DCL. This is all about controlling who has access to your data. With DCL, you can grant, deny, or revoke permissions for users or groups. For example, you could give user 1 permission to select, insert, and update data in the products table. And finally, we get to the Data Manipulation Language, or DML. This is where SQL really shines. It's all about interacting with your data. With DML, you can insert, update, or delete specific data in your tables. For instance, the example on the slide shows a select query that pulls product names and prices based on a specific condition. Now keep in mind, SQL is a massive language. We've just scratched the surface here. If you find SQL intriguing and you want to dive deeper, there are some great resources out there like the DP-900 course on querying data with Microsoft Transact SQL, or the Get Started with Querying with Transact SQL learning path on Microsoft Learn. But the key takeaway here, SQL is your go-to tool for managing, accessing, and manipulating relational data. Once you master it, you unlock the full potential of working with relational databases. Tables aren't the only important objects you'll encounter in a relational database. There are other few key players that help make everything work smoothly, like views, stored procedures, and indexes. Let's start with views. Think of views as your predefined SQL queries that return structured data sets, almost like virtual tables. You can query them using select statements just like you would any other table. Views are super helpful when you want to simplify complex queries or hide the complexity of underlying database structure. It's like having a shortcut that lets you focus on the data you need without worrying about the nitty-gritty details. Next up, we have the stored procedures. These are defined SQL commands that can be run on demand, almost like mini programs in your database. What's cool about these stored procedures is that they allow you to add parameters for flexibility in your data operations, like inserting, updating, or deleting records across your data entities. They make repetitive tasks easier and more efficient, allowing you to run complex data operations with a single call. And then we have our indexes. Think of these as the navigation guides for your database. They act like a roadmap for your query engine, helping it quickly find the data it's looking for based on specific column values. By speeding up data retrieval, indexes make your database operations more efficient, especially when dealing with large data sets. Together, views, stored procedures, and indexes, and other objects all work behind the scenes to create a robust and efficient relational database. They empower your applications to securely manage, store, and retrieve data with ease, and they play a crucial role in how we interact with and manage our data. Now that we've covered the concepts behind relational databases, it's time to see them in action. This is the moment you've all been waiting for. Let's dive into some of the Azure resources designed specifically for relational data. First up, we have the original Azure SQL. Azure SQL is a family of services built on the solid foundation of Microsoft SQL Server, one of the leading relational database management systems trusted by some of the world's largest organizations. While SQL Server is widely used for on-premises solutions, Azure SQL brings all that power and reliability to the cloud, offering flexible solutions for just about any scenario. Now, Azure SQL comes in 3 different flavors, each tailored to specific needs. First, we've got SQL Server on Azure virtual machines. This is like having your own virtual database server in the cloud. It's perfect for projects where you need full compatibility with existing on-premises SQL Server setups, or for hybrid environments where you're combining both cloud and on-premises databases. It's the go-to choice if you want full control of SQL Server, but in the cloud. Next, we have Azure SQL Managed Instances. This is a platform as a service or PaaS solution that automates many core administrative tasks, making it ideal for migration scenarios. If you're looking to move your on-premises SQL Server databases to the cloud with minimal changes and without worrying about managing hardware, this is a fantastic option. It gives you the flexibility of SQL Server, but with a lot of heavy lifting taken care of. And finally, we have Azure SQL Database, which is another PaaS solution and probably the most cost-effective option out there. It's perfect for new applications that need a low-cost relational database with minimal administrative overhead. If you're looking for a simple, scalable option without needing to worry about managing infrastructure, Azure SQL Database has you covered. Now, here's a handy tip to keep in mind. The options we've covered are arranged in decreasing order of administrative control and cost. SQL Server on a VM gives you the most control, but also comes with higher costs. On the flip side, Azure SQL Database offers the least control, but it's the most budget-friendly choice. But don't think you're limited to just Azure SQL. Open source databases have become a cornerstone of modern technology because they bring a lot to the table: flexibility, cost efficiency, and innovation. And Azure has fully embraced these open source powerhouses to give you even more options to choose from. First up, we have MySQL, a friendly open source database management system that's incredibly popular thanks to its simplicity. You'll often find MySQL in the LAMP stack applications, working alongside Linux, Apache, and PHP. It's a go-to for developers who want a straightforward, reliable database solution. Next is MariaDB. Fun fact, MariaDB was created by the original developers of MySQL. Over time, it's been optimized for even better performance, making it a strong contender. One cool feature of MariaDB is its compatibility with Oracle databases, offering you even more flexibility in your database management. And finally, we have PostgreSQL. Now, PostgreSQL is a bit of a hybrid. It's part relational database, part object database. What sets it apart is that while you can store data in traditional relational tables, PostgreSQL also lets you work with custom data types, offering you flexibility that goes beyond conventional databases. It's a real game changer when you need more than just the basics. All right. We've talked a lot about databases, so how about we get some hands-on practice with Azure SQL databases? Let's log into the Azure portal and get started. All right, so here we are in the Microsoft portal, and this is where we are going to be doing our demo today. In order to create our relational Azure resource, we're going to click the Create a Resource button, and we're going to search for Azure SQL. Now, the first item in the marketplace is going to be the one that we're looking for and the resource we're going to be creating. So I'm just going to select the Create button there. And we're going to be focusing on SQL databases, but we also have SQL managed instances and SQL virtual machines. But for this demo, we'll be focusing on SQL databases. The first thing we always do when we create a resource is add it to a resource group. And then we're going to give a database name. For this database, we're going to call it AdventureWorks. And then we're going to create a new server for this database. I'm going to call it Data Demos. We're going to add it to the West Europe region. And then we're going to figure out what kind of authentication we want to give this SQL Server database. We have three options: the Microsoft Entra only authentication, both SQL and Microsoft Entra authentication, or only SQL authentication. For this demo, we're going to use the last option, use SQL authentication. And I'm going to give an admin login here. And I'm going to create a password for this server as well. Now, we have to remember this password because we are going to use it later on in this demo to log into this server. All right, so now that we have created our server, we are going to make sure that our workload environment is development because this is just a demo. And also, we're going to keep our compute and storage to the same default option, general purpose serverless. And for the backup storage redundancy, I'm going to shift to the locally redundant backup storage because I do not want to put it in zone or geo because that's extra backups, which we do not need for this demo. So when it comes to the networking part, I'm going to select public endpoint here so that I can connect from my browser into this SQL Server database. If I don't select this, then I will need to go through a private endpoint or create a virtual network through which I can get access for security purposes. But since this is a demo, let's keep it to a public endpoint. Next, we will go to the firewall rules. In the firewall rules, I'm going to make sure both of the options here are ticked to yes, because this is going to allow me to allow Azure services and resource to connect to this server. And also, I'm going to set up my current IP address to be accessible by the server. All right. So let's go to the next step, which is security. I'm not going to turn on the Microsoft Defender for SQL. I'm just going to keep it to not now. And then let's go to the next steps, which is additional settings, where I am not going to change much here, except I'm going to add a sample database in the use existing data part. So I'm going to select sample there, and it's going to add some data so that we have some data already to work with in our database. And with that, we are done with the configuration of the SQL database, and we can just hit review and create. we can see the estimated cost, which is $5.69 USD per month, and also the compute cost for any compute resources that we use. So vCore seconds is the unit we use here. So we can see all the settings and configurations we have set up and just hit create. So now in this deployment, we're actually deploying a SQL database, but we're also deploying a SQL server. So this is going to take some time. All right, so here is our resource successfully deployed. So let's go to the resource, and we can do that by simply clicking the Go to Resource button. All right, so here we have the SQL server name and the database name. Now, in order to query this, let's go to the query editor. And here I'm going to use the SQL Server authentication. Remember the password I told you we're going to use later? That's where we're going to put in the password to log in to this SQL Server. And here we are in the SQL query editor. And I can check my tables. I have a lot of tables because we pre-populated this with some sample data. And what I'm going to do is query that product table that we have here. So I'm going to write a very simple select query here. So select star from sales LT product. And let's run that. And you can see I get the results of this table. This is structured data, right? We have column names and we have rows, and we have a lot of columns here, right? And I can scroll all the way up and down to see all these columns, all these rows. But what if I want to see only a certain set of columns instead of all the columns? I can do that by just changing this query, right? So you can see I have all of these other columns here. And what I can do here is I can just add the column names that I want, like product ID, name, list price, and product category ID. I'm just going to put that from into the next line, and then I'm going to run this query. And now you can see I only have 4 columns. So if I open this up, you see I do not have any more columns showing up. There's no scroll bar available here, right? But instead of product category ID, what if I wanted to see the product category name? Now, this information is not available in this table. It's available in another normalized table that's available in my database called product category. So that's the product category table there. And so I'm going to create a join here to join these 2 tables so I can get that product category information. So I'm going to say join with my product category table. I will need to rename these tables so that I can reference them easily. So I'm going to call the first table P and the second table C. And then I'm going to put the condition of my join, which is on the column that both of the tables have in common, which is product category ID. So P.product category ID is equal to C.product category ID. I'm just going to copy that over there. Now that I've done this, the only thing left for this query is to use the reference in the column names, because if I don't use it, I will not know from which table I need to get these columns. So the product ID, the name, the list price, they all come from my first table, the product table. And my product category ID, I'm going to replace. But I'm also going to rename the product name column to product name, because I'm going to get product name and I'm going to get product category name. So that last product category ID is going to be renamed to category. So I'm going to call it c.name as category. And then I can run this query. And now you can see, instead of category ID, I have the actual name of my category, right? So this shows you how you can get that product category data into your product table doing a very simple join. And these are entities, right? So these are normalized entities to reduce the redundancy of having all the category information repeated in our product table. We create a separate product category table that is normalized and has each category mentioned only once instead of each category information showing up multiple times. And through a join, we can slice and dice this data, slice our product data with our product category data. And with that, we have come to the end of this demo. That was a pretty cool demo of Azure SQL databases. What did you think about it? Hope it makes you curious to test it out yourself. With this demo, we've come to the end of session 2. We have learned about relational databases, how and why we normalize the tables within them, some SQL and other important database objects, as well as Azure services and services available for open source options. This concludes our session. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.